matter change its state? Have you ever given a thought what the various things around us are made up of? I'm sure you must have. Everything in this universe is made up of material which the scientists refer to as matter. The matter exists in three states, namely solid, liquid, and gas. An interesting example to understand the states of matter is of water, since it can exist in all the three states. Ice is the solid state of water that exists at and below a temperature of 0 degrees Celsius. Water is liquid and vapors or steam is the gaseous state of water. The liquid state, that is water, can be converted into ice by freezing, and similarly, the gaseous state, that is water vapor, can be achieved by boiling the water. In a similar manner, ice can be converted into water by raising the temperature. We can thus infer that one state of matter can be converted into another state by changing the temperature and also by changing the pressure. But here we would restrict our discussion to the conditions of constant pressure. Let us now understand how the temperature affects the state of matter. When heat is supplied to a crystalline solid, the kinetic energy of its constituent particles increases. Due to this increase in kinetic energy, the particles start vibrating with a greater speed as before. On further increasing the temperature, the energy supplied in the form of heat overcomes the force of attraction between the particles and causes them to flow, thereby leaving their fixed positions. Eventually, the solid melts and is converted into liquid. Student, it should be noted that the heat is supplied to the solid at constant pressure. This process of melting, that is, the change of solid state into liquid state, is called as fusion, and the temperature at which the solid becomes liquid at atmospheric pressure is called its melting point. The melting point of a solid depends upon the strength of forces of attraction between the particles. Higher the strength of forces of attraction, higher is the melting point. Let us learn some more facts regarding fusion of solids. On heating some ice in a beaker at low flame, you will observe that ice melts at a temperature of 0 degrees Celsius or 273 Kelvin at the atmospheric pressure. It is also observed that even when the melting starts, the temperature of the system remains constant till the entire solid melts, even though heat is being continuously supplied. You must be wondering where this energy goes, isn't it? This heat energy is actually used up in overcoming the forces of attraction between the particles of the solid during the change of state from solid to liquid. As there is no increase in kinetic energy of the particles, the temperature of the system also does not allow any rise during the change of state. The heat, therefore, gets hidden within the contents of the beaker and is called as the latent heat.